Hi everyone, welcome back to our webcast series on integrated data analytics. I'm Jacque Keats, the COO of SMA, the program Lifecycle company, and I'm here with Gordon Kranz, a friend of the firm who has more than 40 years of technical and program management defense acquisition experience managing complex weapon systems development. Gordon, welcome.
Well, thank you very much, Jacque. I'm pleased to present the next section of this webcast series where we'll look at the status of the UAV surveillance program just after the PDR event.
So let's get into it. Gordon, analytics means a lot of things to a lot of people. So how would you bound the topic of integrated analytics?
Integrated analytics in this context means using all available information to develop a balanced view of the program status. Specifically, we will look at the EVM cost, schedule metric trends, and critical technical performance measures at various levels of the WBS. We will use EV cost report, the IMS, and the TPMs to understand the performance issues and associated drivers. To complete the end-to-end analysis, we will review the impact of the performance issues on specific program objectives and show the status in terms of the customer mission.
In our last session, we discussed artificial intelligence, and this is a topic that's getting a lot of attention in trade shows and the press. There is an application for AI in data analytics. Will you be discussing it in this session?
Although artificial intelligence and machine learning are starting to help program teams sort through massive amounts of data to understand program status better, we will not discuss AI in this session. Instead, we will be discussing how to do a thorough integrated analysis of program status that can form the basis for historical data necessary for successful future AI use.
AI is early in its evolution, and we are already seeing impactful applications of these tools because they reduce friction and, as you said, help distill large volumes of information and provide humans with more time to focus on higher order activities, whether these activities are proposals, data analytics, program management, etc. These tools will be critical to the future of program controls and is a topic we will discuss in a future webcast. Now, before we jump into the details of this session, why don't we quickly overview the baseline scenario we presented in Webcast 1. If you missed our last discussion, it is available on our YouTube channel at SMA Wins, and we've just put that link in the chat. Gordon, please get us started.
Today we will use cost and schedule metrics and technical performance measures to understand program status in the context of the overall program objectives. This process helps the program team understand historical performance and trends, providing the program team with the information required to influence the adaptation of the plan for daily management and forecasting of the program performance. We first structured this web series to have 4 parts. We have since decided to combine webcasts 3 and 4 into a single session, which we will outline at the end. Let's quickly review each of the following items. The statement of work describes the work to be done and references the mission objectives. In this case, we are developing a multi-sensor UAV surveillance system. The mission objectives are shown here. These high-level goals are stable and are unlikely to change but form the basis of the lower-level design. Chem biosensitivity and operational flight range are the 2 system objectives we will focus on today. Here is the WBS we decided on last time. The 3 reconnaissance sensors are separate WBS elements since different subcontractors will provide them. The computer will be procured from the GSA catalog, and the application software will be developed separately. The program organization is structured as product IPTs, thus models the WBS. The following 2 slides show the resulting baseline responsibility and accountability matrix with each IPT's control account budgets.
As you might remember from Webcast 1, we used an event-based integrated master plan to form the structure of the integrated master schedule. Here you can see the flow of data from the IMP to the IMS.
Last time we discussed the most critical customer system objectives, chem biosensitivity, and how they relate to lower level TPMs, the sensor weights. and how the operational range is affected by the payload weight.
We will use these measures to help us evaluate an overall system health and status. What other tools do you use to evaluate the baseline?
We did run a schedule risk assessment on the IMS to evaluate risk and identify tasks that may have significant risk and opportunity against achieving the IMS milestones.
For those of you who don't know what a schedule risk assessment is, it employs Monte Carlo simulation to evaluate thousands of program executions using 3-point estimates, best case, worst case, and most likely durations of each of the tasks in the project to develop a statistical profile to identify the achievability of the closeout date, and can also assess the ability to achieve interim milestone dates. Gordon, why don't you talk us through what the schedule risk assessment says about the program?
Okay. Here we see the baseline contract milestone dates. In this scenario, the customer requires the program closeout date by January 25th, 2035. To manage schedule risk, the program manager challenged the technical team to create a schedule that achieves contract closeout earlier, with a target of June 2034. We can see that the team developed a schedule to close the program by June 14th, 2034. Based on the risk indices put in by the technical team, the schedule risk assessment indicates a 0% chance of achieving the June 14, 2034 date. However, over 80% of the simulation runs showed program completion on or before the contract closeout date of January 25th, 2035. The difference between the scheduled and contract dates is called schedule margin.
This is an excellent example of Parkinson's law, which states that work will expand to fill the time available for completion. From my perspective, challenging the team to meet the June date helps the program mitigate schedule risk of achieving the end objective.
Agreed. Note that we only use schedule margin at the end of the program, but it can also be used prior to any interim milestone.
That's a very interesting point. I've seen several programs where the schedule margin was allocated discretely for each key event.
The SRA also helps to identify tasks within the schedule that should be proactively managed due to their potential impact on the closeout date. In this case, integration and formal testing activities are at the top of the list.
All right, now that we've gotten everyone caught up on what we talked about last time, let's jump into today's webcast to discuss the details necessary to understand the program status.
To do that, I will provide an overview of the current program situation and review the available status data. The program has been executing for 32 months, about 2.5 years, and has recently completed a successful PDR on April 29, 2030. The program performed an EVM baseline reset in April 2030, which would not typically be done on a typical program, but is done here for demonstration purposes. We have 4 months of status data, May 2030 through August 2030. We will use this data to evaluate cumulative and trend data, focusing on understanding the status at the end of August 2030. Program risks from PDR include the chem-bio sensitivity will not meet spec, operational flight range will not be achievable due to excessive payload weights. The SRA at PDR indicated that CDR may be at least 1 month late from baseline. Note, the program approved a chem-bio risk mitigation effort starting in July 2030.
A typical ACAT-1 program has a large volume of data. Now, I often start at the top and work my way down utilizing a management by exception approach to identify where the anomalies are. Gordon, where do you start in this scenario?
I'll start by reviewing EVM status at level 2 of the WBS to narrow our analysis to the areas of most concern.
So what metrics do you evaluate in this analysis?
EVM analysis is about reviewing the current and cumulative costs and schedule variances and the variance at complete. Reviewing level 2 of the WBS, we see that the reconnaissance payloads, the command and control software, and systems engineering elements all have significant variances. The reconnaissance payloads and the command and control software areas have negative variances in cost, schedule, and variance at complete, while systems engineering only has a schedule variance.
From an earned value perspective, the schedule is a leading indicator. With that in mind, let's start with the systems engineering WBS element first.
The systems engineering team has 4 control accounts. 2 control accounts drive the schedule variance: the software systems engineering and the core systems engineering control accounts. These control accounts show a CPI of 1, indicating that they are running to budget, but the negative schedule variance suggests that these efforts were not completed on time. Control accounts 1.6.2 and 1.6.3 also have minor schedule variances, but the CPI is 0, indicating that these efforts have not started. However, the slight variance indicates that they should have.
Right. We have set a 10% threshold for all of the variances, which include the planned to date cumulative variance and the variance at complete.
In looking at the 10% threshold to date at the 1.6 systems engineering level, we are not breaking the threshold requiring management attention. But by evaluating the systems engineering control account trend charts, we see that the software systems engineering effort does break the schedule variance threshold and thus needs to be discussed. To better understand this variance, we will look at the IMS. The document software systems interfaces task has been lagging for 3 months, but is expected to be completed by the end of the month. This delay also pushes out the complete software design and architecture task, and the systems engineering update trace links task. We need to note this and assess how these slips impact the completion of the CDR and the closeout date.
What you just described is why we review the details of the IMS. The IMS is the foundation of the earned value management system and a leading indicator of the potential impacts, providing the longest runway for corrective action. Now that we've sorted out the systems engineering, let's look at the reconnaissance and command and control application software next.
Looking at level 3 of the UAV surveillance sensors, WBS, all 3 sensors are experiencing cost and schedule overruns, with the ChemBio sensor being the most significant. To determine the drivers, we'll look at the control accounts of each of these WBS elements. The following chart shows the overall status of the EO sensor and its respective control accounts. The first 2 control accounts are complete, one of which has a remaining unrecoverable cost variance. A third control account, 13121, has completed work planned to date, but has a cost variance with future work that is also expected to overrun. The EO detailed design control account is significantly overrun and is behind schedule. The control account is outside the threshold to the current plan and is close to being outside of the threshold at complete.
To get more insights, we should look at the lower level details in the schedule and respective work packages to determine what's driving the slip.
Exactly. Let us look at the schedule now. There are 3 tasks in the schedule for this control account. The control account is underperforming and overspending, but the schedule still shows that the task will be completed on time.
Right. Now, I'd expect that the CAM's explanation will describe their recovery plan. Without a detailed review, this does not look possible.
I agree. But before we look at the CAM's explanation, let's look at the EO TPM weight. The TPM estimate is within an acceptable boundary and is technically on track. So it seems feasible that this control account to be completed on time. The CAM explanation as follows. The EA sensor's technical maturity is on track, but the detailed design work has a cost and schedule variance. The same issue causes both. During early simulation runs, the EO design team identified that the EO sensor power requirements may cause cooling issues. During operations, we added a thermal expert to evaluate the results of the simulation in more detail, and they were able to recommend a few design changes that could be easily implemented and complete the remaining work on the detailed design next month as planned. The cost variance is expected to grow from a negative $65,000 to over $108,000.
Agree. However, We should discuss the basis of estimate with the CAM to understand the corrective action to recover performance and any additional cost impacts. This indicates why just reading the cost report and the CAM explanation is not sufficient. Typically, further detailed discussions with the CAM are necessary to understand the issue and the recovery plan.
Next, we will review the thermal sensor and its control accounts. You will see that control accounts 13211 and 13212 are complete with unrecoverable cost variances. The Perform Thermal Detail Design control account has a cost and schedule variance that are significant and outside the current plan's threshold and close to the threshold at complete.
Again, we should look at the schedule for the details on what's really driving the slip.
The schedule shows that the detailed design task is still planned to be complete by early November 2030. Now let's take a look at the thermal sensor weight TPM. The thermal TPM is trending positively and may come in less than its allocated weight. As the CAM explains, the thermal sensor detail design is significantly overrun in both cost and schedule. Although the thermal team is tracking nicely to the weight allocation, the Chem biosensor is not. So the systems architect had the thermal team perform additional analysis on their design to assess the ability of the thermal sensor to achieve a lower weight than its allocation, in case the Chem biosensor is not able to meet their weight requirement. We added an expert resource to our team to accomplish the additional analysis. The current cost variance of a negative 33,000 is projected to grow to over a negative 145,000 for further work to help the balance the payload weight issue. With the additional resources next month, we expect to be able to complete our detailed design by early November as initially planned.
I would expect that the program team to have a more detailed discussion with the CAM to understand the efficacy of doing the additional studies in parallel to the implementation of any findings in time to meet the current plan. It's definitely a dicey situation, right?
Yeah, definitely. Although there seems to be good rationale for the EO sensor and the thermal sensor, the data indicates the analyst should have further discussions with the control account managers. The Chem biosensors control accounts are shown on this chart. You see that the Chem biosensor payload WBS element has a cost variance outside the 10% threshold to plan. Reviewing the control account performance, we see 3 control accounts with significant cost variances, contributing to the overall cost issue seen in the 1.3.3 Chem biosensor payload WBS element. One of these control accounts, the Chem bio detail design, also has a significant schedule variance. The performance trend for that one control account shows that both the cost and schedule variances are outside the boundary to the plan threshold, and the cost variance is outside of the at complete threshold even though has remaining work.
You would think significant variances like these would have emerged in prior periods and likely resulted in the CAM implementing a recovery plan. In this instance, before engaging the plan, we should take a look at the schedule. I seem to have a theme there, right?
Yeah, definitely. Yes, looking at the schedule details should provide additional insights. The program proactively established a risk mitigation plan for the Chem biosensor last month. The mitigation objective is to identify a potential alternative to the current Chem biosensor that meets the allocated requirements. Notice that the risk mitigation effort, started in July, is already 3 weeks behind plan, and the control account is forecast to be completed in February 2031, which is 3 months later than the baseline.
This feels like double jeopardy to me. Now, not only is the control account behind schedule, but the mitigation plan is beginning to slip as well. The program team should identify additional workarounds to recover the schedule. They're in a very slippery slope at this point.
Yeah, exactly. What's interesting is that in reviewing the TPM trend chart, the Chem bio TPM estimate has been trending negatively, but still within the control boundary for the past 5 months. Trying to recover from the negative trend, the program continued to experience cost and schedule variances. This is an example of how TPMs often are leading indicators for future cost and schedule performance issues. And as we look at the CAM explanation, the Chem biosensor is significantly overrun in cost and schedule. The root cause of these variances is the inability of the Chem biosensor to achieve its sensitivity target given its allocated weight. Today's sensor technology cannot be packaged in the size and weight allocated in the current design. The ChemBio team has been authorized to pursue alternative Chem biosensors or sensor packaging to meet its allocated requirements. The impact of this risk mitigation effort is a 3-month slip to the final ChemBio design, which will cause a slip to CDR and the currently planned schedule closeout, but no impact to the contractual schedule closeout since the program has a built-in schedule margin. As the team continues to evaluate alternative vendors, we expect the cumulative cost variance to grow from a negative $158,000 to a negative $268,000, which will contribute directly to the program EAC.
Early on in the program, we identified the Chem biosensor as a risk item and put together a risk mitigation plan. As risk emerged, we were able to implement the risk mitigation plan. This is a good example for the use of both of schedule margin and a risk mitigation plan.
Absolutely. This is the art of program management. You must look at the big picture and not just a single issue. Finally, let us look at the command and control software. Note that this control account is at level 3 instead of level 4 for the sensors, highlighting that all control accounts do not have to be at the same level.
That's a great point. People often force control accounts down to the same levels, creating unnecessary detail.
In this case, we will look at the work package level of detail to understand progress. You see that one work package is experiencing significant cost and schedule variances and a variance at complete. A quick look at the IMS shows that only one work package has started and is projected to end 2 months late to baseline. The UAV surveillance command and control software is clearly struggling and will require management attention. For the sake of time, we will not investigate this issue today. Instead, we will focus on understanding the sensor issues.
Yeah, that's a good summary of the individual control accounts, but we should step back and look at the overall schedule and the SRA to evaluate the impact of these control accounts on the overall program.
Reviewing the schedule, we see that the projected completion of all future milestones has slipped about 2 months, which means that the current schedule is not projected to degrade further. When independent evaluating the current schedule, one might question this projection. So let's review the SRA. The schedule closeout date shows completion on August 17, 2034, but our SRA indicates that completion on this date is not likely. However, with the completion of the program against the contract closeout date, the SRA indicates that there is a greater than 80% chance of success. The tasks that need to be watched closely are the integration and formal testing tasks, which is consistent with the SRA that was done on the baseline schedule. The schedule margin has been reduced from 161 days to 115 days.
Yeah, it's a good practice to look at the interim events and the end of the program to determine near-term impacts and alternatives to recover the schedule.
Good point. We have an SRA output with the CDR as the sensitivity target, indicating that the CDR is projected for completion in July 2031, but is not likely to be completed on that date. However, it is more likely to be completed by mid-September 2031. Looking at the tasks in the schedule, we see that the ChemBio risk mitigation effort must be managed closely to avoid further degradation in the schedule. This next slide shows the status of the critical system objectives we have chosen to track for this exercise. As we saw earlier, the ChemBio sensitivity is outside the acceptable range and the overall payload weight is not good. We see that the current projected operational range is on the verge of not being achievable.
Gordon, there's a lot of data here to digest. So how do you boil this down so that a clear recommendation can be made to the program management team?
Good question, Jacque. Folks need to remember EV helps the PM team identify areas of concern but does not identify causes or recommended actions. The technical team needs to take these areas of concern, look for the root cause and recovery plans, and establish recommendations for the PM. Let's reflect on what the data is telling us in each of the areas. For technical, the TPMs for the EO and thermal sensor weights are tracking to plan, but the chem biosensor is significantly out of bounds and trending negatively. These negative trends indicate future costs and schedule issues as seen in the variance at complete projections. Although the operational range requirement is still within bounds, it is at risk. For schedule, the program level schedule variance of -2 million is driven by the development of the sensor software requirements, which affects both the command and control software development and the completion of the systems architecture task. Most of these issues will be resolved in the next 2 months, but they will likely negatively affect the variance at complete. The program has experienced significant cost variance, primarily driven by the inability of the chem biosensor to achieve a design that meets its allocated requirements. The current program level cost variance is -1.6 million. The cost variance will continue to grow in the sensor development and spread to the command and control software development, with a program level variance at complete of a -2.8 million. The program EAC is projected to be $101.9 million.
Wow. This is a great analytical summary. It's an important reminder of the order of insights from metrics we use for performance analysis of the program, starting with technical, schedule, cost, at completion metrics. Equally important is the root cause analysis and the resulting recommendations for the PM. So Gordon, as you said earlier, this is the art of program management. You must look at the big picture, not the individual issues.
Yes. In this case, the EV analyst recommendations follow. The program management team should track progress on 2 efforts to help avoid any further degradation to cost and schedule. The chem bio risk mitigation effort and the system engineering effort to rebalance the sensor weights are the 2 efforts. Since the chem bio risk mitigation work has the most significant negative impact on the schedule, the program team should consider adding a resource to crash the schedule. For the systems engineering effort to reallocate payload requirements, the program management team should closely monitor the potential reallocation of requirements to provide the chem bio team enough allocation to meet its requirements with the current design. In that case, we would be able to stop the risk mitigation effort and finalize the chem bio design earlier than currently forecast. The systems engineering team expects a recommendation by the end of November 2030. In parallel, the program manager should work with the customer to determine if any relief can be made on the system level requirements if the program needs to pursue this option.
From this discussion, you can see the importance of not only looking at the cost and schedule, but looking at the technical parameters is critical, particularly to get a clearer look at the impacts and the mitigation activities. There's no doubt that all of this will ultimately find its way into the EAC.
The PM's EAC looks relatively optimistic,
Indeed,
given the issues we see in the program. That is why the customer performs an independent EAC analysis to assess the realism of achieving the remaining milestones.
And that leads us to our next topic for the next webcast, which will focus on independent estimate at complete.
In that webcast, we will evaluate the contractor's EAC using a variety of metrics and develop an overall assessment of program achievability.
Now, are there any questions in the chat? Okay, well, it looks like we've got a couple questions here.
Excellent.
Yeah, quite a few questions, actually, I think. I think the first one is from Holly. She's saying that she's just here to say that tracking really doesn't change anything, and allocating resources has a chance of correcting the situation. Do you want to comment on that?
Sure. I guess I'm not sure tracking changes actually doesn't change the history, but it can change the future.
That's correct.
So you want to look at the technical performance in the past to see if you're headed in the right direction, and if not, and in some cases, in order to if you're falling behind, and in order to accelerate that activity, you would allocate more resources or that sort of thing.
Yeah, and I think part of this too is, remember, all of this is collaborative, right? None of this happens in a vacuum.
Right.
And these aren't silos. So the program team, which includes program controls, engineering, et cetera,
Right.
are working together. And so when we say tracking, it's that we're putting it on our radar screen. We're watching it, making sure, do we need to actually, is there a reason to implement the risk mitigation plans?
Exactly.
Do we need to apply more resources to this, et cetera? And you don't let it go until you hit the brick wall and then make a decision, right? But it's that old adage, what gets measured gets managed, right?
Exactly.
So I think the next question is from Lucky. So he says, I'm surprised that you wait until 10% threshold to sound an alarm. How is the 10% variance determined? And I think it's kind of a follow-on to what we were just talking about.
Yeah, absolutely. So 10% is sort of a rule of thumb, but any typical program will define exactly what that percentage should be, is where you would want management attention. And in some cases, some WBS elements may actually have a different threshold than others, depending on the risk. Right. But you got to recognize we're not necessarily measuring 10% threshold at the program level and waiting until that breaks. We're measuring very low-level tasks in the schedule at the work package level, and those are typically shorter in duration, and so a 10% variance would be an indicator at a very low level.
Yeah, absolutely. And again, when you say shorter, a work package is probably 3-4 weeks in duration. So, 10% is pretty early in that, in that span of time. Interestingly enough, though, Gary Crystal did a study for the Navy. Oh, this must have been in the 90s, maybe.
Yeah.
That indicated they looked at a large body of programs, and what Gary's study determined was that the first 15% of the overall program execution determines the pace at which the program will be delivered. And so if you were looking at this at an aggregate level, that would probably be too late. But at that micro level, it certainly is appropriate.
Agreed.
Okay, so from Wendy Hilton. She's interested in seeing how to evaluate a contractor's TPMs when conducting an IBR.
Hey, Wendy, how you doing? Excellent question. So remember, the IBR is very early in the program, and what you would want to look for is you'd want to look for the fact that they have TPMs and that they have a time phase projection. You would want to understand how the TPMs related to the system level objectives from the customer, because the TPMs are a lower level view of the status of the program, but they should roll up and provide indicators of system level behaviors. And so that's what I would look for in an IBR is for that traceability and the fact that they've got a time-phased estimate and that it seems to make sense.
Right, and also, the IBR is not an inquisition, right? It's a collaborative activity between you and the customer.
Right.
And part of the reason for conducting IBRs is to make sure that that the entire team, again, the whole program, which includes the customer, is aligned on the things that are going to get measured and the way that we're going to approach, tracking the program itself. And that's why the TPMs are such a critical component.
Yeah.
From Liz. I remember from the last time that you said that the IPTs are a better construct for the program. Can you elaborate on that?
Yes. What we said last time is that what you're comparing is a functional organization for your program or a product organization. And if you have a functional organization where you have software folks, mechanical folks, electrical folks, all separately organized, it's more difficult to understand how their collective work relates to delivering the product. Right. And so that's why if you organize cross-functional IPTs around the products that the WBS is formed by, it's a lot easier to allocate resources, track progress, and manage the program.
Right. And we're particularly in the large MDEP programs, it's a system of systems, right? Yes. So each of the IPTs is delivering a product that gets integrated to create the overall system. So exactly. It also helps the integration process considerably.
Right.
Yeah. From Blake, how often should an SRA be run on the program?
What I've seen is that SRAs are run, initially, and then potentially annually, but for sure around any major milestone or large planning cycle where you've updated the schedule and that sort of thing. But it's not something you would run on a monthly basis for sure.
And, it's interesting because we've got clients that insist on that, right? That they want the SRA every month. And I think that, like anything else, too much of a good thing, can become problematic. I do think, though, that the SRA is a critical tool because it gives you the ability to run a simulation on the program to get a real sense of, at critical points in time, how is the program going to execute based on where we've been or what's left to be done and what risks either are starting to emerge, or have been mitigated, over time.
Yeah.
From Cynthia, I noticed that when talking about the chem biosensor status, the TPM was trending negatively 1 month after the PDR, but it looks as though the program manager didn't take action. Could you explain that in a little more detail?
Yeah, absolutely. I think they're going to bring up the chart.
Yep.
So you see in this TPM exactly what Cynthia said is that after 1 month of status after the PDR, it was still within the control boundary. But at that point, it's likely that the program management team would allocate more resources, do something in order to try to bring it back within the boundaries. And in fact, you saw from our trending cost variances and such that's exactly what had happened. But even those additional resources, you can see that it didn't turn that TPM around because they were fundamentally had the wrong sensor and the wrong weight allocation, and there was just no way of turning it around. And you see that. So there was some action taken, but it was in cost and schedule. And it wasn't until July that they decided that they better kick off a risk mitigation effort to see if they couldn't update the design.
Right. All right, let's see. From AJ. Hey, AJ. Let's see. You mentioned in the presentation a lot about the order of insights. Could you elaborate on that a little bit more?
Yeah, I think what we said was technical, schedule, and then cost.
Yep.
And so why you would look at technical first is because that's fundamentally what you're trying to build.
Right.
Cost and schedule are you're spending money and taking time in order to build that artifact. And so it's important to understand where are you at with that artifact. That's these TPMs, and there's a variety of other factors as well. But that's why technical must be looked at first.
Yep. I think also that, the key behind all of this, again, goes back to it's one team, one fight, right? And the idea that, if you're integrated with the engineering team and you're actually, participating in the review meetings, you're getting those stand-ups and things that happen, you're getting those insights much earlier because they're problem solving, right? During those meetings. Schedule, even if you're doing it weekly, is looking back at the prior week. So, you're probably going to be couple, 2 weeks behind in terms of getting insights as to what's happening. Whereas on the technical side, those discussions are going to happen repeatedly throughout the status meetings.
Right.
Let's see, from Alan. Should you score the EVM process based on the status of the TPMs, and how does that relate to QBDs?
So that's an excellent question, and actually is one of the foundations for why I wanted to do this series. When I was within the department, I had kicked off a few studies. One of the studies that I had done was to basically see how could you use TPMs to try to factor in against the EVM progress. Right. And what we found is that, for example, TPM is size, power, weight, functional characteristics, all that. And there's a bunch of different tasks in the schedule that need to happen from mechanical engineers, electrical engineers, and on, that basically collectively then mature those TPMs. So there's really no way to say, hey, if the TPM is out of bounds, I want to degrade EVM by 10%, because which of those tasks would you hit? That's right. So that's why you independently look at the TPMs with the EV cost and schedule, and if you've got the objective criteria at the lowest level, you should see consistency in what the TPMs are telling you, and what the cost and schedule metrics are saying.
Right. And it gives you that objective measure of accomplishment as well.
Exactly.
Because, as great example, I went to a client once, and he had this little box on his whiteboard that it was all these dollars, and it was all the cost savings they were going to achieve by these cost takeout measures they were going to do, but they hadn't done them yet. And they were trying to figure out how they're going to spend that money on to recover other parts of the program.
Sure.
I said, well, time out. We actually have to implement those things first. So, a lot of this goes back to looking at the technical measures, looking at what's happening with those. I've seen situations where they were struggling with speed. Right?
Yeah.
And it was small changes that ultimately allowed the speed to be achieved. But originally they thought they were going to have to go back to and redesign critical components of the engine, right?
Right.
And so I think that it's understanding that mechanics and not, as you said, not downgrading the EVM in order to accomplish, in order to simply assume it's binary.
Right.
It's either worked or didn't work. It's on schedule or off schedule. Programs are never
Right.
end up like that.
And that's where QBDs come in, is because at the lowest level you've got these set of tasks or work packages where you're defining the objective criteria
That's right.
for what does it mean to be done with those set of tasks or that task. And that criteria is developed with the knowledge of what needs to happen out of that task that will support the ability to mature the TPM, that kind of thing. So it's important that these QBDs are taken seriously and that they actually relate to technical performance measurement.
Absolutely. Nothing could be more true than in software that way, right?
Yeah, exactly.
Definition of done becomes really important.
Right.
Let's see, from Paul. In the presentation, you skipped over the issue of command and control software. Would you consider discussing that in a future webcast?
Absolutely. One of the reasons that I skipped over it is because with hardware, the EO sensors, for example, it's easy for the audience to understand, the size, power, weight,
right.
Some very physical, visual things.
Mm-hmm.
With software, it's a lot more in-depth as to try to assess whether it's technically doing what it's doing. I mean,
right.
You talk about behavioral threads that need to be complete. You talk about, whether, and so it's a lot bigger deep dive and would definitely take, more of a full webcast in order to try to assess that.
Yeah, absolutely. I think that'd actually be fun to do. Both of us have got a bit of a passion about software. With everything you've done with Agile as it relates to EVM, and then of course my history developing software. But the thing about software is that risk manifests itself in a variety of different ways. In terms of we implement a particular technology, say a non-SQL database to
right.
Or an AI solution, and then it's doing what it needs to do, but just not doing it fast enough, so that impacts the performance of the overall system, or an edge case that pops up that wasn't considered. So you're right. There's a lot of complexities to what happens with regard to software. From Sophie. Why would you plan a program milestone that has a 0 chance of being executed? That's a great question.
That is a great question. And unfortunately, more programs than not do that. Mm-hmm. And what I mean by that, they typically don't run an SRA or any other, factor in risk and that sort of thing. But the reason you would do that is that, if you understand the contractual endpoints that you need to accomplish, it's typically a good practice then to challenge your team to try to get that done more aggressively. Right. And as you said earlier, Parkinson's law says that you're going to fill the time that you're allotted. And so if you plan to the contract date, it's likely that they're going to consume that. So the use of schedule margin is a way to help manage schedule risk. And so ideally, you're not really planning for that 0% chance because you recognize that there will be some activities that slip, but you're hoping that it won't slip past the contract date.
Right. And the thing about a schedule is it's fluid.
Yeah.
When you baseline your initial schedule, it has a particular flow, and as you start taking status, the critical path changes,
Right.
the risk starts to change, risk profile of the
Yep.
schedule starts to change.
Yep.
So, originally that milestone wasn't planned at zero probability of completion.
Right.
It's just what's happened over the evolution of the program. And as you said, integrating schedule margin becomes a useful tool in mitigating that kind of performance issue.
Right, and as we mentioned earlier too, is that schedule margin is good practice not only at the end of the program,
Yep.
but for key milestones as well, so that you can kind of
Yep.
keep track of your progress and manage your risk throughout
Yep.
the program life cycle.
Yep, I'm a big fan of the idea of using schedule margin. I know there was several years ago there was a bit of a debate about it in the community.
Yeah. I think there still is.
Yes, I agree with
unfortunately.
you. From Pauline, how do you know you have the right TPMs?
Well, that's a good question, and it's sort of as we discussed in the first session, unfortunately a while ago. But anyway, so the TPMs that you're monitoring are related to the customer objectives.
Mm-hmm.
So when we talked about the IBR, what would you look at the IBR? You'd look for traceability between how the program office is going to track technical progress and how does that relate to the system objectives.
Right.
And so how you know you have the right TPMs is that they're traceable to the system objectives and they help you understand incremental status toward those objectives.
And a lot of those definitions start early on in the program life
Yes.
cycle.
Yep.
During early, the draft RFPs, the RFPs, there's a lot of requirements in those documents that define, how the thing that the end customer wants to buy has to perform.
Exactly.
And those become the inputs to, the TPMs that you're going to measure against.
Exactly.
So from Lucky, are there times when you're measuring metrics where you find you're measuring the wrong metric, or that you need to add more metrics to what you're measuring?
The answer is absolutely yes. When you're measuring things like size, power, and weight, those things are fairly
Obvious.
tangible
Yeah.
and fairly obvious.
Yeah.
But there are some technical measures that related to performance or throughput or that kind of thing,
Yep.
where you might be measuring something and you get what you measure.
Yep.
And as you discover that, and how you discover it is that if you're measuring something and it's providing you with information that seems inconsistent with what's actually happening on the program,
Yep.
you would want to reevaluate those metrics and see if there's other ones that you could incorporate.
Yeah, one example early from my career was when we were developing Tracker, we had actually built a sort algorithm that performed really well in small data sets. And as we started expanding our test case, it started exponentially degrading, and we had to actually go back and redesign the entire sort
Mhm.
function in order to allow the system to perform at the volumes of data we knew we needed to process. And those, so we hadn't even thought about measuring the performance of that aspect of the system.
Exactly.
Okay, so from the studio, and I love this question. This is fantastic. When is the next webcast? And I think we've agreed that we're going to do this on
Yes.
October 17th, and that we're excited about this, and we're going to continue working these series. I think we've got another one that got teed up in this session that we'll certainly give some serious consideration to laying out.
Excellently. And again, we'll be looking at forecasting performance as well
Yep.
as independently assessing the feasibility.
Yep. So, as we said earlier, right, and I think you were just elaborating on this. Our next webcast will take place on October 17th, where we're going to focus on the Independent Estimate Act completes.
And then the webcast will look at, in particular, the contractor's EAC, because as you noticed that there were some things that the CAM had discussed earlier today that seemed interesting, and as we poke into it, we may find that, so we'll be looking at those sorts of things as how they're projecting.
Yep, absolutely. And the Independent Estimate Act completes actually a super interesting topic. We ran a case recently for a client where we implemented, where we actually used that as a way of assessing an EAC, not on one program but on two, and correlating the trends between programs. So we'll be talking about that a little bit more in the future as well.
Yep.
All right, but I think we're not quite out of time, but I don't see any more questions in the chat. So with that,
Excellent.
Well, we'll say we'll see you next time.
See you next
And we're
time.
looking forward to the IEAC webcast.
Absolutely.
All right. Thanks, everybody.